Good evening, everyone. We are Aurora Logic, and today we're presenting our topic, a predictive model for homeless shelter demand. Our team consists of Israt Shahan, Fausto Vasquez, Xin Fu, and Maddie Montalvo, and we're competing in the AI data science track. I'm Maddie Montalvo, and I will be starting our presentation today. The problem is we aim to address the challenge of estimating the population of homeless individuals seeking shelter by using unemployment, weather, and shelter data to predict future shelter demand. The solution is to develop a predictive model that uses weather and unemployment data as factors to forecast shelter demand and enable proactive resource deployment. Our solution enables city agencies and community organizations to organize funding and prepare financially for potential rises in people seeking shelter. We decided on this solution because predicting accurate forecasts can help cities and organizations distribute resources more effectively and support vulnerable populations. Reliable data sets for homelessness, unemployment, and weather are also publicly available, making it feasible to build and test a predictive model within the hackathon's timeframe. By analyzing the relationships between unemployment, weather, and homelessness trends, our solution can help identify when and where the need for support is likely to increase, and our data-driven insights can make a tangible difference in improving the distribution of support services. Technology can help with solving this problem because we used Python and machine learning to forecast how many people might need shelter. We tried handling missing values, standardized dates, and merged multiple data sets into one. With graphs and charts, we could see how temperature and unemployment affect shelter demand. We also tested and improved AI algorithms. I will now be passing this presentation over to Fausto.
Hi, everyone, welcome to the dirty side of data science. Here we decided to use Jupyter Notebook and the Pandas library in order for us to import our CSV files or datasets. The first dataset was the DHS daily report for people seeking shelter in New York City. The second one was the weather in New York City. And the third one, unemployment rate, you guessed it, New York City. After we imported our files, we checked our data, and we found that some of our columns didn't share the same format. So we reformatted in order for us to merge all three data sets into one huge data set. Afterwards, we decided to drop all the unused columns, right, in order for us to have our clean data set, right? And our result was this, right? You have blank zeros, 0 on all our columns, 0 values on our columns, and then no values on all columns. And this is beautiful. This means your data is cleaned and you're ready to go. Now passing it on to my team.
In our project, we want to make sure our AI model is ethical and useful for the community. First, we focus on serving the public good by predicting shelter demand. Our model helps city agencies plan ahead and give timely support to for people experience homelessness. Secondly, we ensure ethical and responsible data use. We only use open data, public data sets from DHS, NOAA, and Bureau of Labor Statistics, no private information. Finally, we focus on accountability and improvement. We plan to keep updating our model with new data and make it more accurate and fair over time. Overall, our project uses AI not just to analyze data, but to make a real positive impact on society. Next part, move on to with our teammates.
Hello everyone. So we started our analysis with the correlation heat map, which compares each value of our data set. So if we look at the unemployment rate and the total individual in shelter, we can see a correlation value of minus 0.58, which is very low. This indicates that the unemployment rate heavily influences the number of people seeking shelter. On the other hand, the minimum temperature versus the total individuals seeking shelter is the correlation value is really close to 0, which means there are no correlation between these two variables. Then our next slide is the shelter population over time. if you look at the timeline, you can see that there is a spike in 2023. I think it is a little unusual, but it could be because of COVID. Because of COVID, after the lockdown ended, a lot of people lost their jobs. They kind of started suffering with mental health. That could be the reason why there is a spike in people seeking shelter. And this is, as we discussed before, this line actually is flat, which indicates that there is no correlation between minimum temp and total individual in shelter. And then this is interesting because if you look at the graph, we can see that when the unemployment rate was low, the number of people in shelter was high, which is unusual. But then again, it could be caused because of COVID. But if we look at after 7%, we can see the line is going up a little. So maybe the data is like now being normal. To prove my point, I also checked the unemployment rate over time, and I saw that yes, there is a spike. There is a huge drop in unemployment rate from 2021 to 2022 that is caused by COVID. Moving on to Maddie. Thank you.
We plan to train a predictive model using the training data set from January 2022 to January 2025 to learn patterns between temperature, unemployment rate, and homeless shelter population. Our goal was to apply either a linear regression or random forest regressor algorithm, then test its accuracy using actual data from January to October 2025 to evaluate how well the model could forecast shelter demand. Due to the time limitations and the lack of a large, reliable data set, we were unable to complete the model training within the challenge period. With more time and a larger, higher quality data set, this project could develop a robust AI model capable of accurately predicting future trends in NYC's homeless shelter population, helping city agencies allocate resources more effectively during extreme weather and economic shifts. The challenges we encountered during the development stage were that unemployment data may not be fully reliable. There can be reporting delays, which may weaken its correlation with real-time homelessness changes. Dataset size was also limited. We used the available data from the DHS, NOAA, and unemployment rates to build an initial model, but a larger dataset covering more years and additional factors, such as rent prices or policy changes, would improve accuracy and reliability. Cleaning the data was also a challenge because there were 3 datasets that had different formats, missing values, and inconsistent dates. We standardized, merged, and verified all data to ensure accurate analysis. We learned while working on this solution that after 2021, we could see a huge spike in homelessness due to unemployment, presumed to be because of COVID. We found that temperature has a weak correlation with shelter demand, around -10 to -15%. We initially expected cold temperatures to lead to higher demand. However, the data shows that other factors have more impact. We learned that unemployment has a very strong positive correlation with shelter demand. Our accomplishments were that we visualized temperature versus shelter-seeking population, checked correlations between unemployment rate and homeless population, articulated the importance of homelessness prediction and how our approach can support better resource planning, and we developed an initial predictive framework for estimating people seeking shelter. The next steps involve fine-tuning the model by incorporating additional data sets and external factors to improve prediction accuracy. Thank you. We're happy to answer any questions you may have.